In here, if we try to, for example, let's say that we want to print something like a number in here, let's say number 5, we would get an error, because for printing something on the screen we should always use something called format specifiers. Using the format specifiers, we are telling the compiler that how I want you to translate or interpret the data that comes next. Let me show it to you in example. In here, using the % and d, I'm telling the compiler that the data that comes next, you should interpret those as numbers in base 10 or in the decimal format. You remember in a couple of lectures before in the assembly module, when we created this program, it was some kind of array structure, and we stepped through it using the GDB. In the GDB, we said something like, you use the X command, and we said that I want 1 byte to be interpreted as a hexadecimal value, and then we saw that the D character was translated to 0x64 in hexadecimal, since in the ASCII this D is equivalent to 0x64. Well, the same thing is in here, because everything in the computer is saved in the binary format or zeros and ones. It's our job to tell it that how I want you to translate those data. Now in here, if I say %d and 65, actually let me show it to you in action. So I press Ctrl O, hit enter and exit, and just compile it using the GCC compiler in here, and hit enter. We don't have any problem. Now hit enter, and if you see, we have the number 65 printed on the screen. Let me also put a /n so that it would go to the next line. Now what I want to do, if I change this to X instead of D and then recompile it and execute it again, you see that we have 41 in here, since 41 in hexadecimal is equivalent to 65 in decimal. So in this way, we are telling the compiler, the GCC, that this 65 is in the base 10, but I want you to put or print the related hexadecimal value equivalent to this value. Now if I say C, the C format specifier is for the character. In this way, we are telling the compiler that look at the ASCII table and print the related character that has a code point or a number equal to 65 in decimal. Now if I press Ctrl O, hit enter and recompile it again, but before I execute it, I want to press Ctrl Shift and T and say man ASCII in here. Now 0x41 in hex or 65 in the decimal is the code point for the character A. So in here, the compiler knows that it should print the character A on the screen. If we execute it again, you see that we have the capital A on the screen. And actually we had something like this in our Python calculator. If I enter our Python interpreter in here, we were working with such a thing in previous lectures. You see that we had, for example, the int of 41, and then we said 16. In this way, we are telling the interpreter that I want you to look at the number 41 and then convert it to the base 10, which we have 65 in here. Or if we just say, let's say that the other way, the same way that we did it in the C in here, that we are telling it that I want you to look at the 65 and print the related character to it. In here we are talking to the compiler, and in here we are telling the interpreter using a function called hex. If I give it the value of 65, it would give us the hexadecimal value equivalent to 65. Now in here another, or actually let me just use another function. If I say chr and give it the value of 65, the same thing would happen, and we have the capital A printed on the screen just like this. Now there is another format specifier that is P, and it is for saving the pointers, because right now I think you know what the pointers are. They are just they save the address, a memory address. So in here, if I just execute it, if I compile it and execute it again, you see we have 0x41 because addresses are represented in hexadecimal mode. So in here, the only difference of the P and X is that P has a 0x in here, because memory addresses, if you paid attention in the previous lectures in the GDB, we always saw some kind of format 0x and then a number in the hexadecimal representation.